Hey guys, it's Vince. In this video, I'm going to cover doing the other half of the spindle cable. First video I did was doing a plug spindle cable where we just were installing an HY connector. It was actually a large HY connector. In this video, we're going to be doing the ring connectors, and of course this is for the VFD integration. So this is where your spindle power cable will plug into your VFD. So first thing you're going to want is all your tools laid out, and I recommend laying them out once again in an organized fashion. Stay put soldering jig, this is what I'm using. Kester 186 RMA flux, Kester number 44 solder. Everything I'm covering is either available when you purchase one of my DS Flexion spindle cables, or if you want to buy the stuff separately. So the soldering jig, the stay put, that of course is available separately, as well as my solder kits. And then of course we also have our ring connectors, heat shrink, that all comes with the DS Flexion cable when you purchase it. This is single wall heat shrink, which will be used to formulate the boot on this end. And of course we have our 18 gauge silicone lead that is a shield drain extension. So you are going to need preferably a brand new single edge razor blade. And we're going to take this. Once again, this is about 5.5 inches in length. It's just a template that I use. Once again, I would recommend that for you. This is not rocket science, this end. It really depends on how you're mounting your cable. But you can see here how I'm doing this very easily. I then make a score on the cable, leave that. And then what I do is I just fold it, and you can see where that score line is. So if you're tracking that, you want to go slow. You insert very gentle. And now what we're going to do is try to keep that score line centered. That's the optimal way to do this. So we just keep tracking it. Hopefully you should pick that up on camera. I'm going to do it one piece at a time. And again, this is not something you will be using automatic strippers for. This is strictly a slow and steady process. You can see we're right on point. So there we go. Now you should be able to flex the cable. If you're using a sharp enough razor blade, you'll flex it, and that will loosen the casing. Okay, once the casing is loose, we're golden. You can see we're separated right there. You got that little gap. Now we'll come in and incise this very carefully so we can remove the final piece of casing, similar to peeling a banana. Come in with a probe. Probe has a sharp end. You definitely want to watch your fingers with this, depending upon what probes you're using. Mine is relatively sharp. Once again, once we get this, if you're using a proper razor blade, it should be nothing to it. There's our beautiful tin braided copper first shield. Done. Peel it. Should be left with a nice edge. Everything is set there. So now what we're going to do is remove the tin braided copper shield. First we'll put our razor blade back. Keep them preferably out of the way because you don't want to hurt yourself. I do have to select that. Access to the launch stand. Now what I do is carefully slide it down as much as possible. There we go. Don't want to get crazy. Just want to release this just by putting the probe in between. What I do is I leave myself leeway so my flush cutters can go in, and then we start trimming the exterior shield, which is tin braided copper. Okay. Just peel it. One step at a time. Now, if you guys are wondering where is the shield drain, you will see that shortly. It's on the other side. A little bit in the thumb. main thing is that you do not cut the shield. So pay close attention to what you were doing. Okay, now we're left with this bundle right here. I'm going to feather it out a little bit. Again, it's interesting because it's really the same process. If you watched a video I did on installing the HY connector, it's the same process. The only difference is you're doing the ring connector side. So you want to clean this. Cleaning it. Do not worry about your shield ring. Now you see exactly where it is. Everything there is set. Get that out of your way and keep feathering out the hairs from the tin-braided copper shield. You want to do it very carefully. The more level we get, the better off we are. Because the idea, once again, is we're going to put these behind the casing of the cable. For safety. That is not an option. Okay. Okay. You see just how careful I am. I'm just scraping very lightly so that I can straighten out the conductors of that shield ring so I can trim them. You see exactly what we're working with. We do it very carefully. We're in. Okay, that's done. Now we're going to formulate our shield ring into a single lead. Very easy. See how long I'm making this. You want to twine this as nice as possible, keeping it as neat. Now this is not nearly as flexible as that silicone lead that we will be attaching to this to make it done properly. Turn our iron on. What we're going to do is apply some flux. We'll make this solid. Once again, if you watch my other video, you never want to work with any type of conductors that are not solid. And therefore, the only way you're going to make them solid, apply some solder flux. Don't be shy. Once again, temperature on this, you can go probably go 650 to start with, because this is real light, and 650 degrees Fahrenheit. You see how I'm laying. Real nice. There we go. Do another layer. You notice I don't go to the base of the cable naturally for the heat. We don't want to have any type of heat conduction down there, but we want this to remain flexible. And that's it. Now what we're going to do is trim. There you go. Now you can save that and use those in your shop for whatever project you want that you need conductors. It is fully conductive, and you can definitely make traces with it if you require them. Trimming some more of our shield ring, and you can see what we have on this end. Now this is really an end that's much easier to build, only because you have so much space. Guys usually need help with the other end, because dealing with the spindle power connector, it makes things more difficult as you're working in a much more constrained space. Okay. Looking good. Okay. That shield is now taken care of. So what we do is we work on one shield at a time, clean our work area. Say that all the time, and I mean clean. There you go. Now what we're going to do, bring our heat gun over. We're going to heat it up. Many of you are familiar with this process as I did it on the opposite end of the cable. Nylon probe. Do not fight the cable. As it cools down, just reheat it. You do not overheat the casing. Take your time. The gun is set at 450 degrees Fahrenheit, so it is not cool by any means. So you have to understand the heat you're working with. If you're not comfortable doing this, hire the appropriate help. Switching over now to a sharper probe, metal. This gives us depth. Use this with caution. It is a sharper probe, so you want to be very cautious with that. That conductor is perfect. Everything looks good. Okay. Now we have one shield done. We are going to now work on our mylar foil, which is our secondary shield. Peel it back like a banana. See our cotton separators. Get them out the way. And we're just pulling it back from our conductors so we do not have any problem putting in our flush cutters to make a small incision so we can begin the tearing process. Okay, after we've peeled the largest piece of mylar foil off, you're always going to be left with the smaller piece. You can see it right here, right where the yarn separators are, because of course they're much longer. So just get them out of your way, fold your conductors down, take your flush cutters, go in between, once again in a vertical format so you don't risk actually nicking any of your conductors. And then what you can do, if you're careful, use the right amount of pressure, you can begin the tearing process using your flush cutters. And just pull it away. Do the same thing here. Wherever there's a piece, it's the easiest way to do it. Done. The lower you can get towards the casing, the better off you are, naturally not mitigating safety of nicking a conductor, because that'll make you start all over again. Good. Okay, now we're just left with our yarn separators. We're just going to take this, lay it out. Once again, you do not want to do a bunch of these, or I should say I don't recommend doing a bunch of them at a time. I usually do about 2 so I can keep it nice and clean. Once again, rotate your cable. You're always working your cable. And if you're not comfortable with your hands working a cable, I would tell you right now, once again, hire a professional to do this, because you are going to be using your hands a lot working this cable, rotating it, maneuvering it. You can see how I'm doing this. I lay the flush cutters nice and parallel with the casing so we do not nick it. Everything here must be done with care, or you start over. Unless, and I hope you guys aren't, because I figure you guys are watching this video because you want to do it right. Like I said in the previous video, do not be that it's a good enough guy. It's a good enough guy usually will end up with a shop fire. And I've seen it time and time again, be very, very careful with working with these cables if you're not comfortable working with them, or if you're in a rush. Don't be. Once again, take the yarn separators. In this case, I think I've got 3 here. You can see how I'm, once again, laying the flush cutters down and snip. Done. Now, you're always left with a little fur coming out. Once again, I come in, pull, and pull away. Inductors are folded the opposite end. Good. And there you go. Everything here looking beautiful. Now you will always have a piece of cotton on the inside that may be longer. I've said this in the previous video. We're working on the other end. Just leave that, you're fine. You will find that it will easily be seated once we go to bottom these out inside the casing. Done. Okay, we're looking good. Our shield drain is the only thing that's now exposed. And now what we're going to do is clean up this end of the cable. Once again, grab a heat gun, clean your desk, everything neat. Let this come up to heat. Grab our nylon probe, work it in. Just turning the heat gun off because I'll have to edit out all this noise anyways, so if I can try to keep it as quiet as possible when I'm speaking, it makes less work on the back end. Okay. And many of you already know why I'm using a nylon probe, is we don't want to have any punctures on our casing. Once again, details. Turn this heat gun back on and keep working it until we're happy with what we have. Now we're going to go in the middle. Remember that one little piece of cotton was in the middle. That's what we try to do. Get that nice and clean. We'll run it one more time. Same process. Patience. I've said this in the previous video as well. Do not come home after an 8-hour shift, stay up all night, and think you're going to do this with the level of detail it requires. You're not. Your best bet is to be well rested, give yourself ample time, especially since I've done this now for over a decade. You haven't, so prepare for the worst, hope for the best. That means naturally giving yourself an allotment of time far greater than what you think you need. Okay, looking good. We're going to switch over to our sharper probe. Once again, I go with the metal. Just check depth. You can go surgically in the middle, very, very carefully. You're in. This is looking fantastic. Just be patient. Now you go. Okay, final heat one more time. Let's just relax everything. Done. Okay. Everything there nice and clean. We just have our shield drain. Once again, the shield drain is left longer, so we can always manipulate it. You can always remove, you can't put back. So cut the shield drain longer. Note to self. Now, we have our conductors here. And of course, there's an possibility of you getting exact length conductors. So what we want to do, and I just usually step on the cable, and I'm looking at, once again, where I want my conductors to fall, because we know that, or we should know, that our ground is going to be inserted into the VFD on the right side. So the cable will be laid like this, essentially. So now the question is, where do the leads fall in? Meaning, where do I manipulate them to where they're not fighting each other as much? I just naturally manipulate them and keep manipulating them until everything looks the way I want to mock up, so to speak, where we are going. Take this, pull it down. That lets me apply tension. And you can see our white lead is slightly above our black lead, and so on and so forth. Okay? I'm adding tension to hold this. Everything is nice and neat. Hold that. And that there is nothing you can do about. It will go everywhere. But that will get your leads right where they need to be. So everything here I'm just holding, making sure we're good. And we are looking pretty good there. Come over here a second. I think we look good. That looks very nice. The closer you can get these to exact, the better off you are. I cannot emphasize that enough. Of course, shot everything out of the way. That's okay. It's going to happen. Clean this up after, but we'll get this immediately clean in this general area. Okay. I hate a mess, guys. No offense, but I do. Okay. We're all set here. We have our conductors laid out. Cable will be rolled slightly so I can have those conductors lined up, but you can see right here we are set. If I step on this, bring it down, and again, if you're stepping on your cable, please pick a surface that is not going to be gritty like a concrete where it's abrasive, where it will cut into the casing, where you're basically destroying your cable. But you can see what we got right there. It looks great. Now, we're going to want our vise. Lay the vise in a horizontal fashion. I go underneath the jaws. Did you see how I did that? Underneath the jaws. Soft jaw vise. Non-marring. Come in. Done. Now, I'm not fighting anything. Everything lines up. You're in, right? We look good. Everybody is looking nice. Shield drain, 4 allocated leads. Get close. Now what we're going to do is apply our heat shrink. Okay. Why do we apply our heat shrink? Because if we don't do it now, you've painted yourself in a corner. You'll be SOL. I always cut a longer piece of the 3 mil for the ground. And there you go. Now, most of you guys are getting the kits that are pre-done, and the heat shrink will be virtually the same. It might be 2 millimeters longer. Not much. Bring them out of the way, all the way down. You're golden. Now what we want to do is still double check and make sure your lead length is set. Now, this is up to you. When I'm selling a client's cable, I make sure it's set because the client's got to get the right product. So, again, those are perfect. Everything looks good. We're set to go. You can see here, if I put tension, everything comes down and you're golden. Shield drain, heat shrink, now the leads are good. Now what we're going to do, we've got our stay put. We're going to move this out of the way. We're going to bring this up. We use our mat to once again hold our conductors out of the way. Set your auto strip. I use Nipix, and you can adjust your guard for how low you want your casing removed. In which case, I leave it stock setting, It's all the way up the minimum setting. So I'm going roughly 5 to 6 millimeters, and just come in, done. That's one. Come in just like this. And once again, these are smaller leads, so you can leave your iron set at 650. I'm going to tin these, get them ready. And if you remember what we did on the HY connector, we are just going to tin the tip. We do not want to have massive amounts of penetration on the back end. We want to join these, but we do not want this to become stiff. Done. That's one. You can check it, see how perfect. And again, by lowering the iron temperature when you're doing smaller conductors, you've got a lot better control of how things are going to turn out. So that's done. We go right to the next one. You notice how the mat is actually holding our conductors in place. The idea is never to fight. And you'll find with electronics, a lot of times when you're working, you see a lot of guys fighting themselves. The idea is not to fight yourself. Think about what you're doing carefully. And same process. Tin to win. Done. That's two. Keep them in the order that they were. Double check your auto stripper. Sometimes you'll get casings caught in it. There we go. Once again, my mat is silicone. I highly recommend using silicone. Very, very good with heat. And I do offer them in my store if you don't have one. Done. Perfect. Keep going. Now, this is a good one actually to show. If you look at these leads, you can see these are shiny. This one's got a little dullness to it. And that dullness is because the flux burned off before the lead was actually accepting the solder. So if we touch it again, just at the tip, you'll see that shine come right back. A lot of guys get worried about that, and that's all that is. Sometimes you don't put enough flux on, or you should double flux, and you'll find out just how fast that is. That one jumped away. Usually I'm lucky. I keep them pretty much condensed, but that's okay. That's what a broom is for. Okay. Once again, apply your flux. Once these are tinned, ready to go. Very easy. Done. Now, you can always do double flux in between. Hit it again, and look, perfect. That's why I said the flux is your key. These are all set to go now. Everything is set. I'm not fighting anything. Okay. Next. Now you want to organize where you're at, and I use my stay put. Why do I use my stay put? Why did I design my stay put? Because I needed something that was precise, and most of the units on the market are just complete shit, and that's just putting it mildly. This, totally adjustable, all steel construction. You have adjustable thumb screws that you can actually lock in like a socket, so you have more leverage when you're adjusting with your wing nut to apply the proper amount of pressure to keep the adjustments where you need them. Something else a lot of guys don't think about. Right now I've got 2 of the adjustment bars screwed in, but if you didn't want it this size, meaning you don't want to have 2 adjustment bars, you could just screw in 1 adjustment bar and go right to the jaw and give you even more clamping pressure. So this unit, every base has been covered. It'll last forever. That was exactly why I designed it. Now we adjust where we are at. I can pull my vise up. This way I can take my conductor and give me just the length I need. I do fine positioning now with my stay put, and you can see I'm short. So what I'm going to do too is I trim my leads slightly, because you don't want them to exceed the ring connectors area where they're going to be inserted. So this area right here that's cylindrical, We don't want this to come above it. So what we do is we make a slight adjustment. Done. And you're right there, and you can see it's still coming above it, so we just keep removing. Finger in front, drop your piece, and you're golden right there. All right, guys, so once you get that conductor cut at the end to the appropriate length, so we do not exceed the circular portion of the ring connector, you'll check your fit, and you can see that's perfect. And now what we want to do is you want to naturally make sure that you're square on top. You don't want to have your connector pivoting this way, left or right. That'll make sure that this seats properly. Everything here is now set. I'm going to apply flux, because when tin this connector, you want to do this correctly. Make sure your iron's hot, and of course your tip is clean. In order to do so, I'm going to come in here. I'm at 650 degrees. Get a little bowl of solder. Come in. You'll see that capillary action. Just pull it. You can actually hear it. Come in again. We're now going to apply flux also to our conductor and to the connector inside. You can see that little bowl of flux sitting there. Now we're going to come in again, clean the tip. And these ring connectors have a seam. I'm going to be applying the solder right over the seam. And then I will push gently, bringing in the conductor inside the connector. And it will go just like so. Done. That's one. Let's see how we look. Okay, we can come in a little bit more, so I'll just straighten it up. And you see now why the stay put is such an important device. Now I apply a little flux on top because I know that that flux is more or less like water, and it's going to go right into the seam and allow me to do the same thing with positioning. I'll just come in, wait for that solder to melt. And again, I'm doing it very gently. And done. Now, flawless. Just got our flux, everything there is set, and if you look at that fill, right on top, let me just get that, so you got a little contrast. Right here, flawless. We'll clean this up. Now, I've said this in the other video for the large HY, you technically do not have to clean this flux. I like cleaning it because, again, presentation is everything. And your client, I want to make sure has the best product. That's met perfectly. Everything there is money. You can see just how nice that came out. Once again, we have a smooth top. Everything there is good. No flexing. Everything is perfect. You may get a little flux splash on your conductor. Just wipe it with a little of your flux remover and it'll come right off. So we're set. Now I'm not going to insulate this. That will be done at the end. But if you look, when I let go of the conductor, it stays, meaning that ring connector is flat. Everything there is perfect. Move to the next. I put that under, grab my blacks, and I stay in order going to the black lead and then moving forward with the remaining leads. Insert your new ring connector. Process is the same. Once again, we check for length, and you can see we're slightly longer than that cylindrical portion on our ring connector. We'll use a flush cutter, once again, finger in front to capture that piece that's going to come off. Done. There it is. Throw it out. And perfect. Let's go over. Everything here, if you take your time with, you will get perfect leads every time. So now we're going to do the same process. Let that iron heat up. Now my iron goes into standby. Yours may not. However, if it doesn't go into standby, keep in mind your consumables, you'll go through much faster. So come in, ball, capillary action, done. Apply your flux. There it goes. We also want to make sure we're still square. Everything's good. If it's not, you just make an adjustment. Come in here. Always apply flux to all components. And we apply it again. Now I'm going to pull down it. Also, I'm keeping that conductor straight. Come in, insert. Capillary action will do its thing. Perfect. Let's see. Almost. We're almost there. We're almost bottomed. A little bit of space. Again, they're using the appropriate heat. You're not worrying about melting anything. It'll all go basically by itself as soon as you get the appropriate heat set. You'll notice that you've got a little time to play with it. I'm not cooking anything. I'm very, very gentle with this. Done. And there you go. That's two. Do the same thing. And we'll just clean it. Now, if you get a slight bead of solder on top, you can either trim that with a razor blade, or you can use more flux inside. Just like that, because it's like water, it will track. Now you can come in and it'll level itself. Let's see if we can. I'm not going to apply any solder on here. I'm going to go cross now. I'm just going to touch it. And there we go. And I still got a little tail, so I'll just trim that piece and you're golden. All that extra solder went in and you are set. Okay? Now, as we go through, do this right real quick. Razor blade straight edge. Very carefully, because solder is soft. I'm just leveling it with the conductor, and I come in, and the reason I'm doing this is we don't want any rough edges with our heat shrink. Okay? Done. Razor blade back, everything clean, and we are golden. You can see that right there. It looks beautiful. So right now we're all set. Once again, conductor is set. I will check length comparison on both to make sure everything I'm doing is symmetrical, like that. Okay, you check everything, because once you get going, there's no room for error. Go to the third lead. Once again, you notice I'm not fighting anything. Everything is staying right in place. Grab our next conductor. Now we're going to come over here. When I say conductor, just so everyone knows, I'm talking about the ring connector. Once again, lead is slightly going past our cylindrical portion of the ring connector. We'll bring it down. What's that? Up. Done. Let that iron heat up. Process is very, very smooth once you stay symmetrical with each one. Get a feel for the bubble. Done. Once again, we apply our flux. Done. Done. Check. Make sure that lead is straight. It's not pulling left or right. You'll notice that in your fingers. You feel any tension, you know you need to straighten it up. Grab yourself enough solder. You can always remove a little bit if it does squeeze out like we just did. I'm just inserting very, very slowly. Perfect. That's us. That's why I say we just keep staying smooth Slow is smooth, smooth is fast. Very simple. I'm just checking. Got a little bit of space. If I do have a little space on the casing, I will just do the same process over again. Clean it so you give yourself more visualization. You'll notice that with the flux, sometimes you get a haze. If you can't see, just clean it, touch it. Come in again, clean again. And we'll keep doing it till we get it right. Once again, once the conductor's already seated, it's really not difficult at all. Right there. Perfect. That's what we want. That seam is beautiful. Don't want to disrupt it. Beautiful. And that's golden. You'll also notice the fill once again changes. And you'll always see that fill inside there. Let me just grab for continuity. You can see how nice and filled. Perfect. We're golden. And you can always feel too, if you feel any rough spots, don't be afraid to hit it with the razor just to make sure. You can always see it. I don't know if she can see it on camera. If I feel a rough spot, I'll always touch it just to make sure we have perfect seal when that heat shrink goes over without any jagged edges, because naturally we don't want to have any burrs that would penetrate our heat shrink, God forbid. So we're golden. Right here, once again, check your lengths. Very easy. Okay, moving along. Now we just fold this. Now we're getting to the ground. This is where guys tend to have a lot of questions. You'll see it all done. Shouldn't be any questions. Same thing, same process. Coming in, a little short, but just come forward a little bit. That's the cool part about using the vise. Once you understand how to use it, you can make slight adjustments very, very easy. And once again, I see a little flux on our white lead. Get that off. Done. Clean them guys up. Once again, we are protruding on our conductor going past the cylindrical portion. Do that. Now this lead is slightly different. You see that's perfect. Before we go to apply, like we've done on the others, apply flux, we're going to apply flux externally on the side of that conductor so we can apply some solder. And this is so we can attach our shield ring. So come over here, just touch. And you guys, let me just rotate this a second. There it goes. You can see that little bit of solder on the side. And that's exactly what we need for a contact point for our shield drain. Now we will come in and we will hit this with flux. Then straighten that lead up just a tear. Perfect. Make sure this is also hit with flux. Perfect. And now we can. Very simple. Come in, make sure that's fitting. I'm just double checking this because I know we have to still tin and everything is good. Okay, we got a ball. You'll also notice that piece of solder actually got not only cleaner, but it also spread slightly. And that's exactly what we want. So we double check everything, make sure we're straight. I also have silicone on the end of the stay put. I do include that with all orders so that it'll hold everything nice and it will last forever. Cannot be burned by your iron. Put some flux in there, perfect. Some flux on here, perfect. We'll go with it. Okay, we're good. Done. Do not worry if you get excess solder on this. That's totally normal and that looks great. Because that excess solder will also be molten once we apply our shield drain, which we're going to do right now. That'll go right there. So let me show you how this is done. You're now going to grab your Knipex. Once again, leave the adjustment set stock all the way back about 5 millimeters. Got it? Catch. This is silicone, and these are tin leads, so you're definitely going to want to make sure you get proper solder penetration. Apply some. We're going to tin them. Just keep coming. And it builds. Now I leave a little heat on there because this is low heat. You'll see it turn, and it's perfect. I'm going to trim this. You get ugly ends, don't be afraid to trim them. It's not rocket science, guys. And always check, if you're going to trim them, check and make sure your conductor, if all these conductors are sealed right with solder, you'll notice they're all filled perfect. So now we're going to come over here. We're going to apply flux once again, and we are going to tack solder this. And then we will run everything through our heat shrink, but you'll see this first because this is where it gets interesting. Come over here, add a little flux, come up. Now I'm going to go a little hotter with my iron because now I'm using a larger conductor. I've got the ring portion of, or excuse me, the cylindrical portion of the ring connector, and then I'm also going to be soldering and generating heat not just from the conductor but also to over here on that cylindrical portion where the solder is. So I want that all to bind. That's important for safety. So once again, 750 degrees. Now I switch my iron temp just that fast. Now what I'm going to do, I'm going to come over here, hold my fingers up, keep pressure off, and the idea is just to drop that bead. Done. And we should have something now. Not making contact. Okay. That's the beauty of doing things live. Now, if you get any type of fill like that, that's good. We just do this. And one more time. Done. Perfect. Come over again, and we'll drop it again. You will do this until we get this right. This time I'll go on the other side. Come on this angle, wherever I can get it to get that bead on there. Tack one, you can see it. Just that fast. This way I'm not disturbing what I just did with the contact lead going into the ring connector. So that the actual lead, the one for the ground, we don't want to desolder what we already did. So you better be careful when you do this because that's the goal, is that we're hitting, we're doing it quick. Done. You notice I'm applying heat, taking it away. If I see more flux, I'll just add it. You got a bubble of solder right there. And that solder now is perfect. All we're going to do is add flux and let the flux wick and basically level that solder. That's what we want to do. Done. Very quick. Done. That is what you're looking for. You can see just how nice that is. And if we check the bottom, we've got penetration on the bottom. If you're uncertain, you can always do it again, but that looks really good. I'm going to clean it. I can't really tell with shadows sometimes, so I'll go over it very, very carefully. And we're looking good. Let's see. Clean that also. That'll give us full awareness of what our product looks like. Yep. Okay, good bead on the bottom, good bead on the top. Everything there looks good. We're going to take that, we'll trim this off on an angle. We want no sharp edges. Done. Now what we're going to do is fish this through our heat shrink. Do it very carefully. Silicone is easy, it's nice and soft. And just pull it through. Come up. And you're golden. So what we will do with this, just pull it up. We're not going to shrink this either. We're going to let it go right to where it's going to go. Right here. Perfect. You can see the fit. Perfect. Now, we have a longer piece of 3mm heat shrink. which is then to be used for our shield drain. This is when things get really interesting because we do not want to make a mistake. We're going to check this once again with all of our other conductors to make sure everything is set. And we just look for the ring connectors ends, and you can see those are dead nuts on. So again, we're golden here. Take them in their previous order and do not fight them. Boom, boom, boom. They just kind of fall where they go. Now what we're going to do, we're going to take, and you can see right here that the shield drain is much longer than required, okay? So we left it that long, and now I can cut this to where it is more applicable. Right about there is perfect. Take the excess naturally, 86 it. Now we come over here. Now this is the thing you have to keep in mind. When you're cutting your shield drain silicone lead, you want to have a little play in it. And the reason you do want a little play in it is when the cable flexes, if it's close to where it mounts to your VFD, you don't want tension on it. So we have to look at that. What I like to do is just cut this with flush cutters after this is being pulled on, so you can see exactly what you got. You want your cable nice and straight. And you want to come over here and cut it past slightly. I would say about a little over a quarter inch. And the reason I'm doing that is because then I have adjustment. I can come back, I can come forward, I can do whatever I need to do. Heat shrink should be cut in a length that exceeds where the shield drain is cut. I don't know if you can see that. I'm just showing you the length difference. See it? And I'm doing that so that we're going to have all that excess heat shrink on the shield drain extension silicone lead so that we have a nice good bond. Now I'm not using adhesive back heat shrink here, so this remains flexible. Some guys have asked me that before. If you glue the shield drain to the heat shrink, it becomes more of a bind rather than able to move because it's an active cable. It's going to move. The main thing is that it's insulated. That's really what we are trying to do. So now what I do is I move out all the other heat shrink out of the way. We still have not touched them yet. And what we're going to do is prep the end of the shield drain that needs to be attached, or I should say the shield drain extension, the silicone lead that needs to be attached. And for this, I use the same length, and I'm just going to measure carefully because then I will extend the length if required. And I'll show you what I mean. This is all by feel now. This is not trying to keep my hands out of the way so you can see what I'm doing. So now you can see how much longer this will be if I do that, meaning it's leaving slack on this end. I don't need that much slack, so I'm going to show you what I'm going to do. If you run into this same issue, very simple. First, we're going to tin this because it's much easier to work when the conductors are all joined. Let our iron heat up. I will be going to 750 on this because we're going to be conducting a lot of mass there, so meaning heat conduction. So we'll do that. Add one more flux. This is coming up. Just let that sit. You're not going to melt silicone too easy, so you're going a little more flux. Same principle. And that's what you should see. Now we're set here, and what I'm going to do is take my 90-degree flush cutters, get the flux out of the way. You want nothing in your way. This allows me to precisely adjust where I want to incise this, rotate, and pull. Now this is all together. I can then come over here and extend or, once again, retract the shield drain lead based on how much slack I need, okay? Critical. Now you also know I'm not going to solder this in the close proximity of where these conductors are without properly insulating first. So that being said, I just need a piece of double wall. There you go. That's cool. But what I do is take a thin piece of double wall, heat shrink, that can go back there, and what we do is just snip it. So what we're going to do is make an insulator, okay? And you want this to go in between the shield ring, and that will just diffuse any potential heat from going onto our conductors. So once again, we've got a nice bond here. This will look gorgeous once it's attached, and we're set. Do not want to forget our piece of heat shrink. Apply that. And again, remember, go slow. I'm doing everything here very, very slow. The main reason I am is because I know if I screw up just because I'm on camera, remember guys, I don't get to make a mistake with this. I'm doing this live. So if I make a mistake, we have to redo the whole video in that portion at least. So now what I'm going to do is apply flux. And that's us. Let this get hot again. And you can fish if you choose to. If you need more space, you can fish this under your leads if required. In this case, I really don't. I just need to have these flat, and I should be able to have clearance there for my iron. Even if my iron made contact with that heat shrink, no big deal. I mean, that's not going to hurt nothing. And that's exactly why you're doing it, because you'd rather it melt than potentially making contact with a conductor. So I'm coming in real careful now. And we're just going to go boom, like that. Done. You saw how fast that was. And like magic, she can show you that joint is perfect. Okay, now what we want to do is see what kind of slack we have. So I'm just laying everything out, and I'm looking at how much slack is left in here. And that's quite a bit, actually. That's not too bad. I like to leave a little bit. I got a little gap there. I can come in a little bit more with that. So all we do now is heat it up, bring it in. Because once again, when you have length, you can do that. That's not a problem. Now in this case, I'll wrap it, show you what I mean. Come right here. Shield drain is still flexible, not too flexible, so you got to be a little careful with that. And now what we're going to do is that same process. I'm going to come over here and I will heat that carefully and bring it in. Same thing, we're going to apply some solder, very, very careful. Right to the tip. When in doubt, add flux again. Hit it again. Right there. That's us. Making sure we did not hit anything, and we're golden. See if we came in a little more. Not too much. Okay, let me undo this again. That's why I say this is all trial and error in the sense of how much clearance you need. Nothing is going to be exact. So if you're trying to get it exact, the easiest way to do it would be, once again, cut it over length exactly like I'm doing here and then just work it. So you're in. Now I have to be very careful because I'm moving my insulator back, so I have a little more room to manipulate, and we should be good. See a bit. You see it's just melting a little bit. That's fine. Well, we're golden. And now we've got it back right where it should be. That looks good. We'll pull this out. Insulator's out. You can see the heat definitely did what you didn't want it to do to the conductors. So I'm glad it showed you that on camera, and that's exactly why I do it. See this? You got a perfect joint there. That's not going anywhere. Check and make sure you're symmetrical. Everything looks good. This looks good. It's bound very nice, and everything there, it's set. So now what we're going to do is check again. Remember, your leads have to be straight to give you symmetry, and you can see how much slack we have in here. So then this heat shrink will come back and properly insulate and be done. So, and in order to do that as well, we'll come over here, because this is not rocket science. Now you can get to see exactly what all the fruit of our labor has been for. And I always, if you're going to have one conductor be slightly longer, having your ground be slightly longer is not a problem, but this came out fantastic. You can see the slack in the shield drain and everything is set. Check our base, as we always do. And you can see that soldered perfectly. Everything there is perfect. Got penetration on both sides. Everything looks good. Clean everything. Well, we're in. Now, here's what we do. Now I come on the top side of the vise. Mount that. Take our probe. I'm going to get the insulators out of the way, meaning the heat shrink. I'm adding a little pressure on my 3mm heat shrink so it stays in place to the base of the cable. And that's it. 380 degrees Fahrenheit on our heat shrink for this, and you see how beautiful this came out. So really very simple once you've done it. You're not going to burn any conductors. Just make sure you're careful with how close you get in terms of not letting the metal make contact with any of the PVC, and you're fine. Done. Okay, that portion's done. Now what we're going to do. Now we've got our insulators here, and the reason I do this last is because I want these to be as symmetrical as possible when I come up. Feel, make sure they're smooth, and now we make adjustments. So I'm doing this very, very carefully, as this is the finishing touch, so to speak, on the cable. The big thing here is that you have tension on the cable, so we can see what these are going to look like once they're installed. And that's the key. You want to come up and keep their base. Now I do this. For your cables, you may not do this, but I try my presentation to be the best. I know you guys are working hard for your money, and I try to work hard for you. So that's just it. Okay? Come over here. Same thing. Bring the conductor up. Excuse me, our insulator up. And we'll just keep working. Now I will do this until it is required to get, once again, what we're looking for. That looks very symmetrical. That's exactly what we want. Keep coming up. You can always feed it up a little more. And as long as this insulator is covering where the base, that circular portion of the ring connector is, you're fine. Okay? So, just so you know, that is what will be looked at, God forbid, in the event of an inspection, will be looked at. So pay attention to that. Heat shrink is very important for insulation. Now what we're doing is this. Now remember, if your cable is bent, you're going to notice that you can see the tension. See how the tension is changing? Even this close, you can see that they're getting pulled on. So you want to be careful, and once again, that's why we left slack. So what I'm doing now is just leveling the cable, and I will come over here and straighten this so we can test everything, make sure we're level. And that's what we're looking for. Guys that are short, they'll come in, and they'll keep coming in. Okay, that looks good. Come back with you a little bit. This is the easiest way to do this. Now we're set. Now the ground, of course, is going to be slightly longer, so we don't worry about that. I'll just pull it up. Try to level them on the top. Very easy. Get them very close. And that's it. Okay. Now we have something, boys and girls. That looks very nice. And that is exactly, push that one back. That's why I say you got to be very careful in what we're doing. Now when we go to apply heat, we want to hold these in this position, but we don't want to burn our desk. So where can we do this? I get asked this a lot. I'm going to come right here. And we're going on the silicone. Why are we going on silicone? Because silicone has a very high heat resistance. then this should not cause an issue, and we should be golden. Just looking at that from above. Once you do this, you cannot go back. Am I straight? Looking straight. That looks good. Hitting them. Lock them in place. Good thing about silicone too is nothing will move. You'll notice that. Once it hits, that's it. Try to hold them a second just to let everything relax. There you go. You can see it for yourself. Those are done. They look very nice, very symmetrical. And that's exactly what you want. I mean, naturally, everything has got its imperfections, but you can get it very, very close. And it looks much more presentable. Now we know that the cable has been assembled correctly. Everything here is right. Final presentation is our boot. Once again, cut perfectly square. Let's clean our desk. Retract our solder. Remove our stay put. You don't need it. Remove our flux. Clean our flux. Your tools, guys, are everything. Okay, now iron off. No point in burning our consumable tip. Clean it. Done. Check your edges. Everything good. Now we'll come over here. We'll install it. This is when you'll see if you did everything else right, because it'll make it all forward. Very simple. Just squeeze it slightly. Like magic. Bend your cable a little bit. What you can see is if the leads are not straight, you want this to be virtually right on. There we go. Okay, now what we're going to do, I'm going to come down a little more because this has got to have a little bit exposed. I would say probably 2 inches or so. And that 2 inches will allow, once again, for our leads to move. And that's exactly what I'm doing now. I'm just reseating them. So everything sits nice. You'll notice your shield drain, and everything sits in here very gently so the client can manipulate as required. Here's where the base of the cable is. And now I'm just taking that shield drain and just working it. Give us our best product. And that's it. Okay. Next, now that we've got this done, I'm going to rotate it, and that's all set. I'm going to now formulate the boot. You can see all the contact point between the base of the cable. Now, in order to do this, I'm going to stop short. You'll see as I go down. First, we're going to use the precision heat gun, and I stay underneath where the base of the cable is. I mold one side in, stay low. You'll notice I'm low, and now I'm coming in slightly, very slow, and that brings it up. You're working your heat to shape with. So again, now I'm definitely going to switch to the other heat gun once I get a little clearance. But the idea here is we're formulating a boot. And you notice that means the boot is not fully shrunk. And the main reason we're not, I've had clients ask me that before, why isn't it all the way shrunk? Because you want flexibility. If you shrink it all the way, you have no flexibility. Then you don't have a boot. What you're doing is essentially making one piece, and that's not what we want to do. As you can see, we've got a nice seam here going. It's almost level. Now it's level. And you see exactly what I'm talking about. And with this low heat, you're not going to do any damage. At 380 degrees, it's going to start shrinking. It's not going to be excessive. You can control it very easily, and that's the whole idea. is that we control it very, very easily. Make sure your conductors look good. Everything here is looking nice and folding right in. So now what we're going to do, switch over our heat gun and let this cool for a second. And then I'm going to shrink this with the larger heat gun all the way down. That finally shrinks it, and you can see presentation then once again for our client. That conductors really fall right into place. There's really not much you have to do to them. So that's all set. Then we'll continue with the final step. That's it. Looking good. Okay. Now you see your seam. Everything is set. We've got our flare point, so everything in here can move. The leads are not under any stress. Everything here is flawless. Now, what we're going to do is make it one step better. You never know when the toothpick's going to come up and do its thing. We'll open our vise. Cable in the vise. I'm going to arc this towards me now. If you would be so kind as to hand me the Dremel, I will get to work. This is the creme de la creme right here. And I believe in doing this, and I definitely believe it makes a difference. First, we want to clean our conductors. And the main reason I do this is because these are going to be treated with deoxin. So I just spread them out a little bit. Grab one of my high dollar Q-tips. And I use Flitz polish. You can use whatever you'd like. Flitz is some good stuff. I have a lot of different polishes. It depends on what I'm acquiring. But for this application, I like Flitz. It's very quick. We just take this and just whoop. Now, the reason I'm doing this, once again, let me clarify, because you have guys out there going, that's pretty crazy. Well, no, it's not. I'm applying deoxit gold to these when they're done. This way, this cable will infinitely last forever, and these conductors are also going to be protected. So I'm just coming here with a buffer. Gets it? Touch the light. You'll get that. That's what we want to see. That means no flux residue. Everything is off. Perfect. Done. And I'm doing very low RPM, 5,000. Let the tool do the work. You don't hear the tool straining or anything like that. This is very, very gentle work. All we're trying to do is any residue of flux or fingerprints or anything is gone. And that is what we want. And you can always add a second coat. I've had guys ask me that. But overall, these look like glass. Now we do one more little task. Usually you get a little residue. Did a video on this. Cut a Q-tip. You want a good cotton buff, real easy. Cut a Q-tip, throw some masking tape over it so you've got a shim. And then you can insert it in your Dremel. I didn't charge extra for that tip, but I'll tell you right now, smart guys out there will find a lot of uses for this. This just removes residue. And you can see that turning black right now, which is telling us there is some slight residue on here. And that's it. Very gentle voice. Done. Perfect. Next. How do they look on camera? Good? Very shiny, right? Okay. Okay. Next. The oxygold. And you see them turning gold. These will last forever. And that's exactly what we want for that client. Oop. That is it. Let them dry. And that's it, gentlemen. Now we're going to move on then to testing the cable, and we will do that as soon as these have a chance to dry. All right, guys, the final step in assuring that the client gets the best possible product is we're going to test naturally that we have continuity on the work we've just performed. I also include a pinout allocation for the client so he knows exactly what 3 leads are power, which should be no confusion with that, and of course, which pin is ground. So now what I'm doing is sticking 1 probe in whatever terminal I'm testing. In this case, it's ground, and I've got the multimeter set up for continuity, and you can see we've got magic on ground. So that's good. We'll check the other leads, make sure we have no continuity, which is proper. I do 3 checks on this on each. Done. Move to the next. Going to pin 3. Now deoxit, of course, has been applied to all terminals, and that's black. Perfect. Nothing, nothing, nothing. Perfect. Going to pin 1. So pin 3 is black. Joanna will fill out that. And then we are going now to pin 1, which should be white. There we go. Better leave that a little bit. Done. And go to pin 2. And pin 2 final should be red. Done. One more for good luck. That's perfect cable, guys. She is now all set and confirmed gold. Once again, the client will receive this. I try to build these ahead of schedule. Sometimes that's not possible, depending upon what workload I have. We had a very large sale night, and then we do get those nights where we'll get a lot of different sales at once, requiring different builds. And that's where we leave that lead time as a buffer. So naturally, I can do the precise work required. So again, now you've seen the process, and I wish you all the best. Keep the questions coming. I'll do my best to assist you. And I hope now I've answered all the questions visually of why these cables cost what they do. Once again, I want to make very clear that if you're purchasing a bulk cable, something made overseas, not by hand, not being validated, then you get what you pay for. And there's a huge difference from what you've seen here to what's happening overseas. When we see just a silicone buffer here as far as a stress relief buffer, you can rest assured that's done overseas. They're not going through this process. We don't know what they're doing because you don't get to see the inside of the cable. Once again, I'm going to state something that should be obvious. If they're not willing to show you the work that they do inside of the connector and how they solder everything, then you essentially don't know what you're buying. Think about that when it comes to safety. Thank you all for your support. Take care.